do this before we can go on to trig with vectors. So, P, Q, you got to graph those 2 points. So, P will be at 3, 4. Q is at -2, -1. Okay, we can connect, but where do I draw my vector? Where's your vector actually going? Connor? From P to Q. So your arrow has to be pointing down at Q. How many had that? All right, you got to make sure you know how to draw this. Okay, then we talked about writing vectors in 2 forms, coordinate notation and component form. I only want component form. How many components do you have in a vector? You only have 2, the x values and the y values. So we have an x value of what? Yeah, you have -5, because remember, with your vectors, you always start going to the left or the right. And in this case, we go to the left. So my component form for my x, it's -5, since I'm going to the left. And then I'm going to go down, how many? 5 as well. So it's -5 again. So my component form deals with the greater than, less than symbol. Coordinate notation has to have a coordinate. So it's x, y, arrow. This one would be x -5, comma, y -5. Got to know the difference for the midterm next week. Okay? One word for magnitude. What is it? Distance. All right, so we have 2 ways to solve this. We can use the distance formula, but how many remember the distance formula? Okay, not everybody. I don't even have half. Okay, which is perfectly fine, because what's the other way we can solve this? Pythagorean theorem. Good. Now, when I use Pythagorean theorem to solve for the distance, for the length, what side am I solving for? The hypotenuse. So we're solving for C. What are my 2 values that I plug into the Pythagorean theorem? The 5 and 5. Now, don't forget the negative, but does it really matter here? Nope, because you're squaring it. So what is C? 5 times the square root of 2. How many have that for the magnitude? Good. Now, this is how I had you leave it for vectors. Now we're going to switch gears. For the word problems when I find magnitude, you will actually get the decimal, because we're actually going to be talking about a specific distance. Okay? Does this make sense? Yeah. All right. Now, the other thing that we're going to learn with our vectors is direction. Direction to you normally says north, south, east, or west, right? Which way you're traveling. In a coordinate plane, which way is north? Where's north? Okay, you guys are all pointing, but I want to be specific. Connor?
The positive y.
Yep, the positive y-axis. That's north. So where is east?
Positive x.
The positive x. So then I have south and I have west. Okay? So you got to know those directions. Now, with our vectors, you need to know 2 things. You need to know the angle, and you need to know the direction. Okay, so those are the 2 things you must know in order to tell me the actual direction of a vector. Okay, now, determined by the angle it makes with a horizontal line. So if you look at this red vector, where am I going to get my angle from? What am I going to have to do first? Connor? Right, you're going to have to find the component form and the magnitude. So, remember what we did in the example. We go along the x-axis first, and how far did I go? 4. And then I need to go along the y-axis, which is 3. So then, without actually doing any calculation, what's my hypotenuse?
5.
Why?
Because 3 squared plus 4 squared is 5.
What's that called?
Pythagorean
A Pythagorean triple. Very good. All right, so now if I label this A, B, and C, where am I going to solve for my angle? If I need the angle that it makes with the horizontal line, which angle? Angle A. You must know that first bullet. Must know that. And you must know the third one. So when I ask you for the direction of the vector, you're going to tell me two things. You're going to tell me the degree, and you're going to tell me the direction that it's going, east or west. So really, when I get all three sides, I can use all three trig functions to solve for that angle, correct?
Yes.
Yes. Now, if I use tangent of angle A, that's 3 over 4. How do I solve for angle A? Okay, so tangent of A is equal to 0.75, but now how do I get A? Very good. We need to plug it into the inverse of tangent, so you call up the second tan buttons, okay, and then plug in 0.75. What is A rounded to the nearest tenth of a degree? So 36.9 degrees. Good. Okay, that's half of my direction. Okay? So determined by the angle it makes with the horizontal line, and you describe the vector as a certain degree relative to east or west. Which way is this vector going? Northeast. I don't really mess with my north part. What I end up doing is saying this vector is going 36.9 degrees, and it's relative to east. That is your final answer. And yes, you will need to put relative to east. Okay? Now, I have a question. Why would I have to look at angle A? Why not angle B? Okay, it's not starting from your horizontal and going up. It would be going the other way. The vector would be going the other way if you looked at B. You would have something like this blue one. Does that make sense why we look at A? All right. So the two things that you need to have, if I ask you for direction of a vector, what are they? Good. You need the degree, and then you need whether it's going to the east or to the west. Does this make sense? All right. So do we know how we got the 36.9? Do we know how we got the 4, the 5, and the 3? Okay. Could I have used sine instead of tangent? Could I use cosine? Absolutely. And do we understand why it's going east instead of west? All right.
So what happens if it's not a Pythagorean triple?
Then how do you solve for the hypotenuse if it's not a Pythagorean triple?
Well, do we leave it as a radical, or are we gonna?
No, you will leave it as a decimal from now on. For these problems. For the vector problems, you can have a decimal. All right. So try this one on your own real quick. The vector describes the velocity. So velocity has to do with speed and direction. So what is the velocity of this moving ship? When it starts at point A at 5.5 and it ends at point B at 25.20. You need to find the speed, and then you need to find the direction. Okay, speed is new, right? We haven't found speed. But when you think of velocity, it deals with speed and direction. So really, when it says speed, it's just talking about the magnitude. So really nothing new. Anytime you see speed, you're finding the magnitude. Okay, so try this on your own. Alright, so I'm going to graph this up here. A is at 5.5. The And then B is at 2520. Where does your arrow point to? It does point to B. Good. Alright, so then we gotta find the speed. We gotta find the magnitude. So when I deal with that, what do I have to draw in? You gotta draw in your triangle. Always go with the X first and then the Y. Don't flip that around. Okay? So my X distances, where am I at? You have 20. And then Y, 15, right? So 20 squared plus 15 squared is what? Yep. You'll have the square root of 625, which what is that? 25. So that is your hypotenuse. Now, when we talk about speed, generally, what are our units? Miles per hour. So that's technically what the speed would be. 25 miles per hour. Is everybody getting 25 okay? Just using the Pythagorean theorem. Did anybody use the distance formula and still get that? Perfect. Again, I don't care which way you go with that. Okay? Now, I need direction. So again, what angle am I going to solve for? I'm going to solve for angle A. Do I care what trig function you use? Nope. So which one do we want to use? I heard cosine first. So if I use cosine of angle A, that's equal to what over what? 20 over 25. Now, we struggled with this a little bit on the quiz. What do I do to solve for angle A? I use the inverse. So A will be equal to, you have to see cosine to the negative 1. Okay, you got to find that on your calculator. And then either get the decimal of 20 divided by 25, which is what? Or just type in 20 divided by 25. Either way, what do we get for angle A? 36.9 degrees. And then the actual answer relative to east, because we're going to the east. There's your final answer. And again, yes, I do need you to put it's relative to east. Don't just put east.
So you really need to find the magnitude to get the
You're gonna have to find the magnitude, but it's not totally needed to find the direction, unless you don't have something here, but you always will. All right, any questions on the two things you need for direction of a vector? Angle and direction. Got it? All right. Now, we talked about this idea for vectors to be equal and parallel back in chapter 7. So to be equal, they have to have the same magnitude and direction. So they have to have the same length and the same direction. They do not need to basically start and end at the same spot. They don't need that, okay? But they do need to be the same length and be going the same direction. And then parallel. Bottom line, what this second bullet says is they can never intersect. They don't have to be going the same direction, but they can be. They don't have to be. And they don't have to be the same length. So bottom line, as long as they do not intersect, they will be parallel. Does that make sense? Okay. So hopefully that's kind of review for us back from chapter 7. Now, we talked about adding vectors algebraically last semester, or excuse me, not last semester, a couple chapters ago. Basically, if I have two vectors, what do I really just have to do if I want to put them together? Algebraically, what is it? What do we do? It's as easy as just doing what? Adding them. Adding the x's, adding the y's. Okay? So if I want to add them graphically, you have a picture like this. You don't need to write all of these bullet points down. Okay? But you do need to listen. Okay? So when I add them graphically, do I just take this blue guy and put it on top of the red and say I added them together? Nope. What do I have to do? Try to be specific here with our technical terms. How do I add these graphically? How am I going to add them? You won't have the magnitude. Well, that's algebraically, though. I want to know graphically how I'm going to do this. I want to take the blue and add it to the red. Well, they kind of are in a sense because they're going up to the east. We talked about this in chapter 7. Right, exactly. So you're going to take this guy and add it like that. So bottom line, adding graphically, all you're going to do is take the initial point, add on a terminal point. Initial point, add on a terminal point. So on and so forth. And that's all it says. And then I can add the red to the blue by doing the exact same thing. And what did I just form? A parallelogram. Now, what happens when I add those vectors together? What happens? What do I get? Why do I care about that? What happens when you add vectors together? What do you end up getting? A new vector. So where is my new vector when I either add the blue to the red or the red to the blue? Where's my new vector? From where to where? Be specific. Well, I need technical terms. Kind of. I think you're visualizing it correctly. Where do I start? Where do I need to start for my new vector? Where did both of these start? At the origin. So I start at the initial point, and where do I end? Where the two meet up, the final terminal set. So what do I draw in, really? Another vector, and it's the diagonal of this parallelogram. So do we know how to add graphically? All right. Algebraically, we already talked about this. It's as easy as adding the x's and the y's, and you get your new vector. So you have something like this. Vector u is 3, 5. Vector v is -6, -1. So what is u plus v? -3, 4. Does that make sense?
Yes.
Do I need to graph that out to see the new vector? All right. There's your homework.